The Hubble Space Telescope in operation for over 34 years has proven to be an extraordinary asset not only for astronomers but also for curious minds across the globe. Although originally designed to observe distant galaxies and deep space phenomena, Hubble has unexpectedly become a critical tool for studying our own solar system. In many cases where no dedicated missions exist for specific planets or celestial bodies, its unmatched stability and high-resolution imaging capabilities have filled the observational void, despite certain limitations, such as being unable to capture the entire Moon in a single frame due to its large apparent size. Hubble has still contributed significantly to lunar science. Notable example occurred during the 2012 transit of Venus, when scientists cleverly used the Moon as a reflective surface to analyze sunlight that had filtered through Venus's atmosphere. This innovative method allowed researchers to test techniques for detecting atmospheric compositions, methods that are now widely applied in the study of exoplanets. Hubble's ability to capture global images of Mars has yielded insights that even orbiters circling the red planet cannot always provide. Its observations have documented sweeping seasonal changes, dust storms that engulf the entire planet, and atmospheric dynamics in remarkable detail. In one striking time lapse, the telescope captured Mars' small moon Phobos racing across the planet's surface over just 22 minutes. Reminder that Phobos is the only moon in the solar system that orbits faster than its host planet rotates. Such imagery is far more than visually compelling. It provides vital data for mission planners preparing future rovers and crewed explorations to Mars. These observations inform crucial decisions about when and where to land, what to study, and how to endure Mars' harsh and ever-changing climate. Beyond Mars lies the asteroid belt, a chaotic region of debris orbiting between Mars and Jupiter. In 2019, Hubble focused on asteroid 6478, Gault, which displayed unexpected twin tails resembling those of a comet. Scientists determined that this phenomenon was likely caused by the URP effect, in which uneven solar heating gradually increases an asteroid's spin rate. G now rotates once every 2 hours, nearly the structural limit for a loose rubble pile asteroid, causing material to break free and stream into space. Another fascinating case was P/2010A2, which initially appeared to be a normal comet, but was later revealed to have an X-shaped debris field, evidence of a high-speed collision between two asteroids. Such events offer rare, direct glimpses of the processes that continue to shape our solar system. Traveling deeper into the system brings us to Jupiter, the gas giant, often called the solar system's vacuum cleaner, for its ability to capture or deflect comets and asteroids with its immense gravity. One of the most dramatic demonstrations of this influence was the 1994 collision of comet Shoemaker-Levy 9. After being captured decades earlier, the comet broke apart under Jupiter's tidal forces and its fragments slammed into the planet at enormous speeds. The impacts left dark scars larger than Earth and released energy equivalent to millions of nuclear bombs. This was the first time humanity had directly observed a collision between two celestial bodies, a vivid reminder of Jupiter's protective role. Jupiter also possesses a magnetic field so powerful that it generates the most intense and persistent auroras in the solar system. Unlike Earth's auroras, which are driven by solar wind, Jupiter's glow constantly encircles its poles, powered by the planet's internal magnetosphere. Hubble played a pivotal role in monitoring these auroras, especially during NASA's Juno mission in 2016, revealing that they are fueled not only by solar activity but also by the magnetic interactions between Jupiter and its moons. Among those moons, Europa stands out as a prime candidate in the search for extraterrestrial life. Beneath its icy crust lies a vast ocean kept liquid by tidal heating from Jupiter's gravity. While early spacecraft such as Galileo and Voyager captured surface images, it was Hubble that detected possible plumes of water vapor erupting into space. These ultraviolet observations hinted at a way future missions could sample the ocean without drilling through miles of ice. Further studies revealed traces of sodium chloride on Europa's surface, implying that its ocean may share chemical similarities with Earth's, which raises the likelihood of microbial life existing there. Saturn too has remained a focus of Hubble's work, especially since the Cassini mission ended in 2017. The telescope now provides the only consistent long-term monitoring of Saturn's atmosphere, capturing massive storms and tracking changes over time. This ongoing surveillance not only deepens our knowledge of Saturn but also refines models of how gas giants might behave in other star systems. Even farther out, Uranus and Neptune, visited only briefly by Voyager 2 in the 1980s, have been observed extensively by Hubble, which has tracked storms on Uranus and discovered subtle changes in its cloud patterns. On Neptune, Hubble uncovered a tiny moon named Hippocamp, just 34 kilometers wide, orbiting unusually close to the much larger Triton, challenging expectations about how such a small moon could survive in a gravitationally complex environment. Beyond Neptune stretches the Kuiper Belt, a frigid region filled with icy remnants from the solar system's formation. Although not designed for such distant exploration, Hubble has revolutionized our understanding of it. Before New Horizons reached Pluto in 2015, Hubble produced the most detailed images of the dwarf planet, revealing bright and dark patches that hinted at a dynamic surface. The telescope also discovered 4 of Pluto's 5 moons, Nix, Hydra, Cararos, and Styx's, information essential for plotting New Horizons' safe passage. Hubble has studied other Kuiper Belt objects such as Ares, Haumea, and Make, measuring their sizes and compositions and challenging assumptions about distant icy worlds. In 2014, it located 2014 Mu-69, later named Arakoth, New Horizons' second target. Arakotha's dual-lobed shape and reddish hue suggested it formed slowly through the gentle merger of smaller bodies, offering a pristine record of early solar system history. Hubble's contributions are not limited to planetary bodies. It has provided valuable data on the heliosphere, the bubble of space dominated by the solar wind. By observing how it interacts with interstellar space and planetary magnetic fields, these insights help scientists model atmospheric loss, radiation shielding, and habitability conditions on ocean worlds like Europa and Enceladus. Even from its distant vantage point, Hubble has observed Saturn's moon Enceladus and its plumes, adding to our knowledge of subsurface oceans and the potential for life beyond Earth. In its decades of service, the Hubble Space Telescope has redefined what it means to study the solar system. Initially envisioned as a window to the distant universe, it has become an indispensable planetary science tool. From Mars to the Kuiper Belt, its observations have revealed a solar system alive with activity, complexity, and mystery. As it continues to operate, potentially into the 2040s, Hubble remains a symbol of human ingenuity and a reminder that some of the most profound discoveries can be made by looking closer to home. The Hubble Space Telescope's contribution to solar system exploration is as much a story of ingenuity as it is of technology. Well, its primary mission was to peer into the depths of the universe, tracking the formation of galaxies and the birth of stars. Its versatility has allowed it to become an unplanned yet indispensable observer of our own celestial neighborhood. This dual role emerged not out of convenience, but from necessity. The scarcity of dedicated planetary missions meant that, in many cases, Hubble was the only eye available to monitor distant or dynamic phenomena in the solar system, where space agencies could not afford to send a spacecraft. Hubble's position above Earth's atmosphere and its suite of sensitive instruments filled in the gaps. This adaptability is one of the telescope's most enduring strengths, proving that a mission designed for one goal can be reimagined to serve many, even with limitations such as its inability to capture the moon in its entirety because of its large apparent size in the sky. Hubble has been creatively employed to study our nearest neighbor. A prime example came during the 2012 transit of Venus. Scientists turned a challenge into an opportunity by using the moon as a mirror. They observed sunlight that had first passed through Venus's atmosphere before reflecting off the lunar surface. This indirect method allowed researchers to analyze the chemical composition of Venus's atmosphere without sending a probe, while simultaneously testing techniques later used for studying exoplanets. What began as an improvised approach became a proof of concept that would ripple outward to influence entirely new fields of astronomy. Mars, the red planet, has been another major beneficiary of Hubble's watchful gaze. The telescope has captured global snapshots that no orbiter with its limited field of view could match. Over the years, Hubble has chronicled seasonal transformations, sweeping dust storms, and shifting ice caps in remarkable detail. One particularly memorable sequence revealed the tiny moon Phobos speeding across the Martian disk in just 22 minutes, testament to its rapid orbit, which is faster than Mars itself rotates. These images were not merely beautiful. They were a treasure trove of practical information for mission planners. Knowing how and when Mars climate changes helps determine the safest landing windows for rovers and the most promising sites for exploration. In this way, Hubble's distant perspective complements the intimate but narrow observations of spacecraft operating in orbit or on the ground. Venturing outward, the asteroid belt has offered Hubble opportunities to witness some of the most dynamic and fragile events in the solar system. In 2019, asteroid 6478 G baffled scientists by sprouting not one but two comet-like tails. Investigations revealed that the so-called YURP effect, uneven heating by sunlight, had accelerated G's rotation to the point where material was being flung into space. This event was not an isolated curiosity, but a vivid reminder that small bodies in the solar system are constantly reshaped by subtle forces. Another asteroid, P/2010A2, provided equally rare insight when Hubble's observations showed an X-shaped debris field rather than the diffuse glow of a comet. This unusual formation was the aftermath of a high-speed collision between two asteroids captured in the act of transformation. Such moments help scientists understand the mechanics of planetary building blocks and the hazards that might one day threaten Earth. Jupiter, the behemoth of our solar system, has provided Hubble with some of its most dramatic subjects. Its gravitational pull, so powerful that it can capture or deflect wayward comets and asteroids, earned it the nickname Solar System's Vacuum Cleaner. The 1994 impact of comet Shoemaker-Levy 9 demonstrated this in spectacular fashion. Having been captured by Jupiter decades earlier, the comet was torn apart into multiple fragments that eventually slammed into the planet with catastrophic energy. Hubble's images of the event showed dark scars larger than Earth itself, a haunting reminder of the solar system's violent nature and of Jupiter's protective influence. The planet's magnetosphere, the most powerful of any in the solar system, produces dazzling auroras at its poles. Unlike the auroras on Earth, which depend on solar activity, Jupiter's are constant, fueled by its own magnetic interactions. Hubble's monitoring, particularly during NASA's Juno mission in 2016, revealed the complex interplay between charged particles, magnetic fields, and atmospheric gases that sustain this never-ending light show. Among Jupiter's many moons, Europa has been a focal point for astrobiological curiosity. Beneath its icy crust lies a global ocean kept liquid by tidal heating from Jupiter's gravity. While earlier missions hinted at this hidden sea, Hubble provided some of the most compelling evidence when it detected plumes of water vapor erupting into space. These observations raised the possibility that future spacecraft might sample Europa's ocean without drilling through kilome of ice. Further spectral analysis detected sodium chloride on the surface, common table salt, suggesting the ocean may share chemical traits with Earth's seas. This tantalizing similarity deepens the possibility that Europa could harbor life, making it a high-priority target for upcoming missions. When the Cassini spacecraft ended its mission in 2017, Hubble took on the responsibility of continuing Saturn's atmospheric surveillance. It has documented colossal storms, subtle band changes, and shifting polar hexagons, helping to build a long-term record of the gas giant's climate. Such data not only illuminates Saturn's unique behavior, but also provide analogs for studying gas giants orbiting other stars. Farther afield, Uranus and Neptune, visited only briefly by Voyager 2 in the 1980s, owe much of their recent observational history to Hubble. Uranus, it has tracked the growth and dissipation of vast storms,